the Harvard MIT Mathematics Tournament 2022. The problem is the following: x cubed minus y squared minus 7z squared equals 2018 7x squared plus y squared plus z cubed equals 1312. It's problem number 2, and solve in integers the system of equations, these two equations. So when we want to solve this problem, we want to learn how to solve these types of problems. We have 3 variables. We try to see, can we get rid of some of them, how we can simplify. And also because they are in integers, we want to factorize. So the first thing, if we pay attention, we can see we have negative y squared here, positive y squared here. So if we add up these two equations, so we can get rid of y squared. So let's see what we have. X cubed plus z cubed plus 7x squared minus 7z squared equals 2018 plus 1312. It will be 0. Then we have 330, 330. Now, we can factor from x plus z here. It will be x squared minus xz plus z squared plus 7 times x plus z times x minus z equals 3330. Now, that's very good because in both of them we have x plus z. So x plus z times x squared minus xz plus z squared, and then plus 7x minus 7z equals 3330. Now we know both of them are integers because x and y and z here are integers. So we know this is factorization of 3330. So we should prime factorize. 0 is 25 and 333 is multiple of 9. So 3 squared, if you prime factorize that, times 5 times 37. So if you consider, if you want to see how many ways you can factorize that, the number of positive divisors of, okay, if we want to find the number of positive divisors, we should add up each powers plus 1, then product of them. 1 plus 1. If you want to learn these basic things and also other things, if you had any question, feel free to send message to my WhatsApp number 0098912 and subscribe my YouTube channel to have next videos and turn on the bell. Now let's solve the rest of the problem. So here it will be 1 plus 1, 2 plus 1, 1 plus 1, and 1 plus 1. So here it will be 2 times 2 times 2, 8, 8 times 3, 24. So x plus z is a divisor of here this number, 24 cases, but the problem says integers. So x plus z also can be negative. So x plus z has 48 cases. When you consider x plus z is what, then the rest of this factor also we can say it will be unique and it will be determined. So if we want to consider all cases, there are 48 cases, but we want to do something to consider less number of cases. So let's see what we can do. I consider x plus z, this part and this part. So I say, for example, suppose that this part is, for example, p, this part is q. Now we want to, and p, q are integers. So we want to solve the rest of the problem. Let me copy this part. See, okay. Now let's see how we can solve it. So I say x plus z is equal to p. So we can say z equals p minus x. Now we replace z here with p minus x. So let's see what we have. X squared minus x times p minus x plus z squared is p minus x squared plus 7x minus 7z, which equals 7p minus x equals q. Now, this equation is a quadratic function, a quadratic formula in terms of x. So let's see what we have. X squared plus x squared minus px plus p squared plus x squared, and let's see, negative px, yes, plus x squared, p squared, x squared, negative 2px plus 7x minus 7p plus 7x equals q. Now, the coefficient of x squared is what? Is 3x squared. This one, this one, this one. Now, let's consider coefficient of x. Negative px, negative 2px, 7x, 7x. So it will be x times negative 3p plus 14. Now, the constant p squared negative 7p negative q equals 0. Now we want to use quadratic formula. So I will copy this equation and here we paste it here. Okay. Let's use quadratic formula. It will be 3p minus 14 plus minus square root of negative 3p plus 14 squared, negative 4 times 3 times p squared, negative 7p, negative q over 6. Now, it is equal to what? Negative 14 plus minus, so let's see what we have here. 9p squared plus 14 squared, which is 196. Try to memorize, for example, 1 to 31 squared. Then in many problems you will use them. Negative 2 times 3 times 14, 6 times 14, which will be negative 84p. And this one, negative 12p squared, negative 12 times negative 7 plus 84p, and the rest of that is plus 12q. And then you divide it by 6. Negative 84p and 84p will be cancelled, and it will be 3p negative 14 plus minus 9p squared minus 3p squared. It will be negative 3p squared plus 1 plus 12q. Let's write 12q plus 196 over 6. So we've got x equals this expression. So in many problems, many mathematical Olympiad problems, you will see that we have something like this and it must be integer. So we should pay attention to two conditions. Sometimes one of them is useful, sometimes both of them are useful. What is that? The first condition, the terms inside the square root must be perfect square. Negative 3p squared plus 12q plus 196. The second condition is that this term should be multiple of 6. So here we know that from this part, let me write, PQ is 3330. So if I write, I know that PQ is 3330. And I know that the thing inside square root must be non-negative. So negative 3p squared plus 12q plus 196 is greater than equal 0. So as I said in previous part, I said 3330 has 48 divisors, positive and negative. So I want to now reject that p has to be positive. How? consider case 1. If P is negative, okay? So P cannot be 0 because the product PQ is 3330. So if we reject this part, we can conclude P has to be positive. So here, suppose P is negative, what can we conclude? We say, okay, 196 plus 12Q, let me write, minus 3P squared is less than or equal what? 196. Q is at most what? Let's write. And when we want to find Q at most what, we can say if P is negative, because PQ is positive 3330, so we can conclude Q is also less than 0. So we can say that Q is less than or equal 0, so less than or equal negative 1. So we can say negative 12Q plus this and negative 3P squared. So if we consider this, 196 minus 12 is what? Is 4, and then 18, and then 184. So we conclude 3P squared is less than or equal 184. So P squared is less than or equal 60. Let's check 61 point something. So because P is integer, P is at most 30, P is at most, let's consider absolute value of P less than or equal 7. Now, we know that P is a divisor of this number, and if we prime factorize, it was 2, 3 squared, 5, 37. So we should check what numbers, because P is less than 0, we should check negative 1, negative 2, negative 3, 4 is not divisor, negative 5, negative 6, and 7 is not divisor. We should check only these 6 numbers. Now, in this case, we want to reach again contradiction. So negative 3 P squared, let me copy both cases. In the next part, we have this, and also we should reject these cases. So here, when we consider this, we know that PQ is what? 3330, which equals 2 times 3 squared times 5 times 37. So Q is negative, and because P is this number, P equals 1, 2, 3, 5, or 6, we can say, okay, P is negative 6 greater than equal negative 6. Okay, because it's negative 6 and we know it's less than or equal negative 1. So the thing that we can conclude is that if we want to find Q, Q is what? Q is this number, 2 times 3 squared times 5 times 37 over. So if we replace P with negative 6, it will be what? If P equals negative 6, it will be 3 times 5 times 37, a negative of that. So we know that absolute value of Q is this or greater than this. So we can say Q is less than or equal negative 3 times 5 times 37. So here we say what? We say this equation, if we write negative 3p squared plus 12q plus 196 is greater than equal 0, less than or equal 196 plus 12 times negative 3 times 5 times 37 minus something, minus 3p squared. So it is obvious that this is strictly less than 0, and that's a contradiction. So we've rejected the cases that P is negative. Now we should consider the case that P is positive. So let's write case 2, Q is P is positive. So when P is positive, also Q is positive. Our X is this, and we said the thing inside the square root must be at least 0. We know that PQ equals 3330, which was 2 times 3 squared times 5 times 37. Now, I want to tell that if P is greater than some number, then we reach contradiction. How? For example, you check P. If P is, for example, let me tell you something. If P is the whole number, or for example, if P equals 333, so that will be a large negative number, and here Q will be what? Q will be 10. And you can easily prove that it is less than 0. So we don't need to check all P. So we check P 333, you can check also smaller number 37. You will see again it will be negative, for example, negative 337 squared plus 12 times Q. Q is what when you select 37? Is 2 times 5 times 9 will be 90 plus 196 less than greater than equal 0. So you can easily reach contradiction for this part because you can say, okay, 196 plus 12 times this 0, it's this. And then if you consider, for example, you can say, okay, it is less than negative 3 times 30 squared, which is 900. Here it will be this, and that's contradiction. So we can consider that if P is like this, 30 or greater, then we will reach contradiction. So let's write that. If we copy this part and consider the case that P is at least 30. So because PQ equals 3330, and it was 3 squared times 5 times 37. If P is greater than equal 30, then Q is less than or equal, let's say, 5. So 3 times 37, which equals what? So it equals 3 times 37. Okay, it is equal at most this. So now we can say, okay, it is greater than equal 0. Let me write like this. Negative 3p squared plus 12q plus 196. So you can say it is at most negative 3. Because p is greater than equal this, we have negative sign. So it's at most 30 times 30, which will be 900 plus 12q. It's 111 plus 196. We want to reach contradiction. It is negative 2700, and here you can easily, for example, change it to, or you can write 12 times 111. It is 2221111. Then it will be what? We can write 2331. So if you add up these two numbers, they're all less than. If you add, it will be 8. It will be 12, 1, 3, 4, 5. So their sum will be less than 0, and that's a contradiction. Now, so we can say what? We can say, okay, P we know is positive, it is in case 2, and at most less than 30. Now, let's consider P can be what number? PQ is 3330, and it is 2 times 3 squared times 5 times if 37. So let's see P can be what numbers. P can be 1, 2 is okay, 3, 4 is not okay, 5 is okay. So we count the numbers not to ignore or forget any case. So 5, 6 is okay, 7 is not okay, 8 is not okay, 9 is okay, 10 is okay, 11 no, 12 no, because 12 is multiple of 4, 13 no, 14 no, 15 is okay, 16 no, 17, no, 18, 18 is okay, we should check. 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, and 29. So we should only check these 1, 2, 3, 4, 5, 6, 7, 8, 9 cases. So instead of 48 cases, we only check 9 cases. So let's copy and paste it here. Now we want to check each case. P is 1, so Q is what? 33, 30. Now, if we calculate the thing inside the square root, it will be negative 3p squared plus 12q plus 196, which equals negative 3 plus 12 times 33, 30 plus 196. It has to be a perfect square. One way is to calculate it and see is not perfect square. One way is to consider mod something and reject it. For example, here I consider mod 5, and if I consider this number mod 5, then it equals negative 3. It is 0 plus 0 plus 1, which equals negative 2, which equals 3. And if we consider a square number, it will be positive negative squared, positive negative 2 squared, or 0 squared. If you consider all of them, any perfect square mod 5 should be 0 or positive or negative 1. But here it is 3, and that's a contradiction. Now let's check the second case. P equals 2 and Q equals, so if I want to check if P is 2, so Q is 3330 over 2. 3330 over 2, which equals 1, 6, 6, 5. And our equation is, let's move it a little here. Okay, now let's consider the case that we should consider when p equals 2. Now, negative 3, 2 squared plus 12, 1665 plus 196. It should be a perfect square. So let's see. The one thing again is to calculate this number. Here, if we calculate this number, it will be, let me tell you, you can calculate this and it is equal to 2164. And if we consider square root of this number, it will be square root of that. It will be 142. Now let's check this case. X is what? 3p, 3 times 2, negative 14 plus minus 142 over 6. So it is 6, and if we consider 6 negative 14 is negative 8. And now we can say, okay, it is negative 8, two cases. Negative 150 if it is minus over 6, or 142 minus 8. 142 minus 8 equals 134 over 6. Here it is not integer because it is not multiple of 3. But here x is negative 25. Now, if we pay attention to the equation that we had in the beginning, this part, let's copy this and see what we have here. So x is what we found x. X is negative 25. Now, if you pay attention to the first equation, when x is negative, so it will be negative. Also, this part is negative. Also, this part is negative. So the answer will be negative. It cannot be positive 2018. So we reach contradiction, and x must be, because it is positive, so it is not positive negative y squared. It is not, so x has to be positive. Okay, also you can find x is at least what, but here we only wanted to reject this case. Now, we've rejected when p equals 2. This next case is when p equals, let me write it here, when p equals 3. So q equals what? This number over 3. So it will be this number. Now, if we copy this part again and try to calculate x, it will be what? Negative 3 p squared, 3 squared, plus 12 times 1110 plus 196. It must be perfect square. So if you calculate this, it is 13,489. And you can prove also without calculator. You can prove that this number cannot be a perfect square. If you want to learn without calculator easily how to prove that it is not a perfect square, as I said, feel free to send message to my WhatsApp number. Now, let's solve the rest of that. It is again contradiction. The next one. P is what? P was not 4, 5. Q is what? Is this number over 5, which equals 6, 6, 6. Now, if we check again this, then negative 3 p squared 5 squared plus 12 times 666 plus 196 and equals 8113. Again, without also calculator, you can prove easily it is not perfect square. If you want to prove it is not perfect square, let me tell you how you should prove this. You consider from this part. If you want to learn algorithm completely, send message to my WhatsApp number also in the description. You say, okay, 9 times 9, 81, and then 13 here, 18 times, we don't have any number that plays, for example, 1 here, 1 equals 0. It is one of the basic things. You know how to calculate a square root, and you can send message to my WhatsApp number, so we can work on these things and also many other things. Any hard mathematical Olympiad or any other tournament problem. The next one. When p equals 6, then q is what? Is 33, 30 over 6, which equals 5, 5, 5. And now we can say, okay, again, let's check our formula. Negative 30 p squared 6 squared plus 12 times 555 plus 196. Again, we can reject it by mod 5. So if you consider mod 5, it will be negative 3 and 0 plus 1, negative 2, which equals 3, and it is impossible. So let's consider next case. When p, we set p 6, 7, 8, 9. We should check 9, and q equals 3330 over 9, which equals 370. Now, if we use again this part, we say, okay, negative 3p squared plus, so if I replace p with 9, 9 squared plus 12, 370 plus 196. And again, if we consider mod 5, it will be negative 3. 9 squared is 81 is 1 mod 5. And here it equals 0 plus 1. So it will be what? It will be negative 2, which equals 3. And again, we've reached contradiction. It was P9. We said, okay, also let's check P10. So Q equals 3330 over 10, which equals 333. Now, if we consider this part, negative 3 p squared, which is 100, plus 12 q 333 plus 196 is a perfect square. Okay, again, if we consider mod 5 of this number, let's see what we have. We have 0 plus 2 times 3, 6, 1 plus 6, 1 equals 2. Again, contradiction. The next one. P11, 12, no, 13, 14, 15. P equals 15, Q equals 33. 30 over 15, which equals 222. And then if we check this formula, then let's see what we have. So 3 for the thing inside square root. We have negative 3 p squared 15 squared plus 12 times 222 plus 196. So if we consider again mod 5, it is multiple of 25. Okay, because it is 15 squared. So this part also must be multiple of 25 because it is multiple of 5. If you consider mod 5, then it will be what? It will be 2 times 2, 4 plus 6 equals 0. So it is also multiple of, this expression is multiple of 5. So because it is perfect square, it must be multiple of 25. So you need to only consider multiple of 25. And for consider remainder when divided by 25, you need to only consider last two digits. So the first one is 0, the second one. When you want to calculate, you say what? You say, okay, 22 times 12, 2 times 2, 4, 2 times 2, 4, 1 times 2, 2. So it will be 64 plus 96. And if we consider these two numbers, mod 25, 6 plus 4, 10, 1, 9 plus 6, 60. And we can see that it is not multiple of 25. And because it is perfect square, that's contradiction. Now, the last case that we should check. P equals 18 and Q equals 3330 over 18. And if we simplify, we have 5 times 37, which equals 185. And here, in this case, we have answer. If we check negative 3, 18 squared plus 12 times Q, 185 plus 196. So, if we calculate this number, it equals 1444. And if you want, you can, without calculator, if you want to find a square root, you can easily say consider from here. As I said, if you want to learn algorithm of finding square root or any other things, feel free to send message to my WhatsApp number. Also, for having next videos, subscribe and turn on the bell. Now, this part, you say, okay, 3 times 3, 9. Here we have 5, 4, 4, 3 times 2, 6, and here we want to find. If I consider 9, it is not good. If I consider 8, 8 times 8, 64, 6. 8 times 6, 48, plus 6, 54, and you can see, okay, the square root is 38. So if I replace x is what? 3 times p is 54 minus 14 plus minus what? Plus minus 38 over 6. So let me just copy this part. So paste it here. X is what? 54 minus 14 is 40 plus minus 38 over 6. If we consider plus minus, it will be 2 over 6, which is 1 over 3, which is bad. If you consider plus, it will be 78 over 6, which equals 13. Yes, so x equals 13. Now we can find the rest of the variables. How? Because here, if we consider the first part, here, we said x plus z is p. So because x plus z is p, you can say, okay, x plus z is p. P is what in this case? P is 18. So p is 18, x is 13, plus z is 18. So we can conclude z is 5. Now, if we consider the equations that we had here, let's copy. Let's paste it here. Now we want to find, we found x, we found z, now we want to find y. From first equation, 13 cubed minus y squared minus 7 times 25 equals 2018. And if you simplify, then we can say y squared equals 4. So because in both terms we have y squared y and we have integers, y can be positive or negative too. So also we should check last equation. 7 times 13 squared plus 4 plus z cubed, which is 125. If we calculate that, it will be 169 plus 129. And if we multiply, it will be this plus 129. If you add up these two numbers, 12 and 128, 1 here, we have 1113, and the answer is 1312. So we found here this answer, x is 13, y is plus minus 2, and z equals 5. So we've solved this problem completely.